Alright, so today we're going to spend some time discussing molarity. What is molarity? How does it relate to chemistry? We're going to address all of these sorts of different things with a practice problem. We're going to work through a practice problem and just talk about some things. So why don't I go ahead and read off this practice problem and then we can get started. So the problem reads, if 38.6 grams of potassium bromide is dissolved in enough deionized water to make 2.00 liters of solution, what is the molarity of the solution? The molar mass of potassium bromide is 119.00 grams per mole. Okay, so we're making this solution of potassium bromide and we're trying to figure out the molarity of the resultant solution. So, what is molarity? Well, it's a type of concentration. Specifically, molarity is as follows. So, molarity, sometimes denoted with this capital M here, equals moles of solute divided by liters of solution. So molarity, denoted by this capital M, will equal the moles of solute divided by the liters of solution. Now, do we have either one of these numbers given to us in the problem? Well, let's see. We're going to dissolve some amount of potassium bromide in deionized water to make 2.00 liters of solution. So it looks like we actually have this denominator term here. So we can say molarity equals moles of solute divided by liters of solution. And since we know the liters of solution, I'm going to go ahead and write that value in. We know that the liters of solution is going to be 2.00 liters of solution. But do we know the moles of solute? Well, not quite. We can figure it out, right? We have the mass of solute in grams, right? The mass of potassium bromide. And we have the molar mass of potassium bromide. So using those two numbers, we can figure out the moles of our solute, the moles of our potassium bromide. Once we figure out the moles of our potassium bromide, we can plug that in right here. We'll then have the moles of solute divided by the liters of solution, and that'll give us the molarity of this solution. So why don't we go ahead and figure out the moles of potassium bromide. So we'll start out with this number here. We'll take 38.6 grams of potassium bromide, right? 38.6 grams of potassium bromide. That number was given to us in the problem. Now we can use the molar mass of potassium bromide to convert to moles of potassium bromide. Let's go ahead and do that in the next step. So we're going to take this mass here and we're going to multiply by this molar mass. So we'll put 119.00 grams of KBr in the denominator, and we'll put 1 mole of KBr in the numerator. If we set our conversion factor up like this, as opposed to the other way around, we'll get grams of potassium bromide to cancel out, because we have grams of potassium bromide in the numerator over here, but then we have grams of potassium bromide in the denominator over here. So because we have it in the numerator and the denominator, those units will cancel out and we'll be left with moles of potassium bromide. So let's go ahead and just cancel out our units. Grams of potassium bromide, grams of potassium bromide. And then we can figure out what that value is, right? So let me grab my calculator. So we're going to take 38.6 grams, and we're going to multiply by 1 mole, and then we'll divide by 119.00. So 38.6 times 1 divided by 119.00. Alright, and that gives us a value of 0.3243 moles of potassium bromide. Now, because this number has 3 sig figs, it's our least certain factor, right? Our answer should only be certain to 3 sig figs. So we're going to underline our third significant figure here. Okay, so now we have the moles of potassium bromide. Remember, potassium bromide is our solute, so we can plug this value in right here, and we can figure out the molarity of this solution. So let's go ahead and do that. So we'll put 0.324 moles of potassium bromide up here. So now we can take the moles of our solute and we can divide by the liters of our solution, and that will give us the molarity of our solution. So I grab my calculator again. So we'll have 0.324 moles of potassium bromide divided by 2.00 liters of solution, and that gives us a molarity of 0.162 molar. So that's our final answer here. This is the molarity of our solution. So let's just quickly sort of recap what we did here. We had 38.6 grams of potassium bromide, and we dissolved that in some deionized water so that we had 2.00 liters of solution, right? And we're told that the molar mass of this potassium bromide is 119.00 grams per mole. And so to figure out the molarity of this solution, we use the definition of molarity, which is the moles of solute divided by the liters of solution. Now, we had the liters of solution, right? That was given to us in the problem at 2.00 liters. So we plugged that in for the liters of solution. We didn't know the moles of solute, but we could figure that out, right? Because we had the mass of solute in grams, and we had the molar mass of our solute. So starting with the mass of our solute, the mass of potassium bromide in grams, we use the molar mass as a conversion factor right here to figure out the moles of potassium bromide present. Now we had 3 sig figs here, 5 sig figs here. Our answer should really come out to 3 sig figs. So I underlined the third sig fig here for the moles of potassium bromide. Then we could plug in the moles of potassium bromide up here, the moles of our solute, and we could figure out the molarity, right? Moles of solute divided by liters of solution gives us the molarity of this solution. There you have it, folks. That's how you can sort of determine the molarity of a solution. If you have any questions, just let me know in the comments, and check the description, because I'm going to try to put a practice problem in there with the answer to it. So if you want to have some more practice sort of calculating the molarity of a solution, just go ahead and check the description below. And like I said, if you have any questions about what I did here, just let me know in the comments. Alright, that's enough for one video, so thank you for watching, and take care.